Welcome, my dear learners. Today's lesson is just a continuation of what you have been doing this very week. Remember, we are still on change of subjects, and today we are looking at relations involving squares and square root sign. And that is what we are going to look at. We are going to look at equations or formulas that involve the square root sign. Remember, this is the symbol for the square root sign. We are going to look at equations that involve this and then a variable b squared. This is what we are going to look at today. Now, when you have a relation or a formula that involves the square root sign, that involves this square root sign. Now, what you must do to do away with the square root sign is that we square both sides of the equation to do away with what the square root sign. Also, when you have a formula or a relation or equation that involves a squared variable, to do away or to cancel the square on the variable, we take the square root on both sides of the equation to do away with the squared variable. So before we take examples, let's go through the following. They are very important, so we take note of them. So the first one that we shall look at is so let's take note of this. You can write them at a corner in your notebook. So the first one is when you have, let's say, root of m is equal to t. Now when you have root of m which is equal to t, our intention is to make m the subject of this equation. But we realize that m is under the radical sign. So to do away with the radical sign, we square both sides of the equation to cancel the square root sign. So it is going to be, we have root of m is equal to t. So we square both sides of the equation to cancel the root sign. So we have m is equal to t squared. So we can see that our m here is equal to t squared. Very, very simple. But remember that in indices, the root sign is the same as what? A power of what? Half. So when you have root of m is the same as what? M power half. So root m which is equal to t is the same as m power half which is equal to t. Now I realize that you want to make m the subject of this relation, but m is to the power of half. So to make half vanish, what must we do? What we are going to do is to multiply here by 2. Do you see that? By anything we do to the left hand side of the equation must be done to the right hand side of the equation. So you can see that this 2 will cancel these 2. We are left with m power 1, which is the same as m is equal to t squared. So that is why we have m is equal to t power 2. Also applies to cube root of m is equal to t. So we want to make m the subject, but m is under the cube root sign. So what we are going to do is we have cube root of m is equal to t. So to do away with the cube root sign, we multiply both sides of the equation by a power of 3. So that this 3 will cancel the cube root sign. We are left with m is equal to t power 3. So you can see that from here, our m is equal to t power 3. So we can continue and then see that when you have an nth root of a certain variable, let's say m, which is equal to any variable, let's say t, and then we want to make m the subject, then we are going to multiply both sides of the equation by a power of what? N. So we have nth root of m is equal to t. We want to make m the subject, so we multiply it by n, by n, so that n will cancel the n root. We are left with m is equal to t power n. So therefore, we can see that our m here is equal to t power n. Very, very simple. So this is the concept I want to pass along. Kindly note it, write it somewhere, and then you read through. Okay. Now also when you have let's say t power 2, t power 2 is equal to m. Now our intention is to make t the subject of this equation, but realize that t is squared. So what must we do to take away the square? Now what we can do is that we have to take the square root on both sides of the equation, or we square both sides of the equation. So we are going to square both sides of the equation, so that this square will cancel the square root sign. We are left with t is equal to root of what? M. Very, very simple. So that is what I was saying earlier. So when you have a relation or equation which involves a squared variable, to do away with the squared of the variable, we have to take the square root on both sides of the equation. And when you have an equation or a formula which involves a square root sign, to do away with the radical sign or the square root sign, we have to multiply both sides of the equation by a power of what? 2. So we are going to get m is equal to t power 2. And if it is cube root, we multiply both sides of the equation by a power of 3. If it is n root, the same thing. This is the concept that I want to pass along. I guess you are following. So let's take examples and see how best we can apply this in solving questions. Okay, so we take our first example. So we have our first example. So this is our first example. We have to make u the subject of the relation v is equal to root of u plus 80. Root of u plus 80. So let's write the question here. We have our v is equal to square root of u plus 80. So realize that the variable we intend to make the subject of the relation is under the root sign. Okay, so we are going to apply some of these concepts. But before we do that, we have plus 80 here. So we have to move this 80 to this side of the equation. So we are going to transpose 80. So we are going to get v minus 80 is equal to square root of what? U. Now we have root of u. Now it is similar to root of m. So what must we do? We squared both sides of the equation. So we are going to square here and then we square here. So that this square will cancel the root sign. And we are left with u is equal to v minus 80 all squared. You can also write it u is equal to v minus 80 all squared. You can leave your answer in this very form. Don't go through the stress of expanding this. You can leave it in this very form. Let's take another example. So we have our second example, example 2. We have to make G the subject of this formula or this equation. Good. But you realize that the variable we intend to make the subject involves a square root or is under the radical sign. Okay, so we are going to apply the earlier concept that we have learned. So let's start. So let's write our question. We have t is equal to 2 pi multiplying L over G. Good. Now, to start with, seeing the variable that we intend to make the subject is under the radical sign, we can first multiply both sides of the equation by what? 2, by a power of 2 to do away with what the radical sign. Or we can also divide both sides of the equation by 2 pi so that it will be left with what? This. Anyhow you do it, you are going to get the same answer. So what do you suggest? Let's divide both sides of the equation by 2 pi first, okay? So let's divide here by 2 pi by 2 pi. So that this 2 pi will cancel this 2 pi. We are going to left with t all over 2 pi is equal to the square root of L all over G. Now there you can see it clear. You can see that the variable we intend to make the subject of the equation is under the radical sign. So to do away with the square root sign, what must we do? We square both sides of the equation. So let's square it here and then we square here. So that these 2 will cancel the radical sign. So we are going to be left with t squared all over 4 pi squared is equal to L all over G. So let's continue from here. So we have t squared all over 4 pi squared is equal to L all over G. Now realize that we have a fraction at this very point. So what we are going to do is that we are going to multiply both sides of the equation by the LCM of the denominators of the fraction. So these are the denominators. We are going to find the LCM of the denominators like the previous one that we did. So our LCM is going to be 4 pi squared times G is what? 4 pi squared G. So this is the LCM. We are going to use the LCM to multiply each term within the equation. Or we are going to use the LCM to multiply both sides of the equation. Is that clear? Good. So we are going to get 4 pi squared G multiplying t squared all over 4 pi squared is equal to the LCM 4 pi squared G multiplying L all over G. Now our intention is to do away with the fraction so that the question will become very simple for us to solve. So in doing or removing the fraction or the denominators, we can do that by multiplying both sides of the equation by the LCM of the denominators. I guess you are following. Good. Now I realize that we have 4 pi squared here, 4 pi squared here. So 4 pi squared will cancel 4 pi squared. Now we are left with gt squared. G times t squared will give you gt squared is equal to G is here. So G and G will go. So this G will cancel this G. We are left with 4 pi squared times L will give you L. 4 pi squared L. Now we are not yet done. We are not yet done. So we want to make G the subject here. So what do you think we can do from our previous lesson? Realize that G is multiplying t squared. So to make G the subject, we divide both sides of the equation by what? T squared. T squared. So that this t squared will cancel t squared. We are left with G is equal to 4 pi squared L all over t squared. Very, very Simple. I guess you were following. Good. Let's take another example. So we have our third example. We are to make t the subject of this very equation or relation. So let's solve it together. Solution. Let's rewrite the question. So we have our r is equal to the square root of t minus 3 all over 9 minus t. Good. Now you realize that the variable t that we want to make it the subject of the relation is under the root sign or under the radical sign. So we first have to remove the radical sign before we can proceed. And as I said earlier on, when you have a variable that you want to make it the subject and it is under the radical sign, we square both sides of the equation to cancel what? The root sign. Good. So looking at this, we are going to square both sides of the equation. So we square here, we square here. To realize that the square will cancel the radical sign. Now we are left with r squared is equal to t minus 3 all over 9 minus t. Good. Now looking at this, or at this well point, we have a fraction which is in terms of 9 minus t. Now we have to clear the fractions. How can we do that? We can clear the fractions by what? Finding the LCM of the fraction. Now realize that the LCM of the fraction is still 9 minus t. We are going to use this LCM to multiply each term within the equation, or we are going to use the LCM to multiply both sides of the equation so that we can do away with the fraction 9 minus t. I guess you are following. Good. So we know that our LCM is going to be 9 minus t. This is our LCM. Good. So we are going to use the LCM to multiply both sides. We are going to get 9 minus t times what? R squared is equal to t minus 3 all over 9 minus t multiply 9 minus t. So we realize that 9 minus t will cancel 9 minus t. Now we are left with 9 minus t multiplying r squared is equal to t minus 3. Let's continue it at the other side. So right now we have 9 minus t multiplying r squared is equal to t minus 3. Now our intention is to make t the subject of this equation. But realize that we have t here, we have t here. So we have to expand this. We are going to expand this very part, okay? So that we can group like terms and then we factorize. So let's expand this very part. So we have 9 times r squared will give you 9r squared minus t times r squared will give you r squared t is equal to t minus 3. Good. I guess you are following. Now realize that we have t here, so we have to group the t's together, or we have to group like terms, okay? So we have t and t, so let's group them together. So let's bring this r squared t to this side, okay? And then let's bring the minus 3 to this side. So we are going to get 9r squared, which is this. We are transposing the negative 3, it becomes positive 3 is equal to, we have t here, and then this minus r squared t We also go to the other side. We have plus r squared t. Good. I guess you are following. So we want to make t the subject. Realize that we have t here, t here. So we can factorize the t out. So we are going to get 9r squared plus 3 is equal to, so we are factorizing t out. We are left with 1 plus r squared. Good. Now our intention is to make t the subject. So what do we do at this very point? So we have, let me rewrite it here. We have 9r squared plus 3 is equal to t multiplying 1 plus r squared bracket close. So let's divide both sides of the equation by 1 plus r squared, 1 plus r squared. So realize that 1 plus r squared will cancel 1 plus r squared. We are left with t is equal to 9r squared plus 3 all over 1 plus r squared. Very, very simple. To realize that t has been made the subject of the equation. Okay, now I'm going to give you one question. You try your hands on it. I'll write the suggested answer below. So after working it, you check if your answer is in line with the suggested answer. Okay. So we have our third example. Now with this one, we have a formula which involves a squared variable. And then the variable we intend to make the subject is squared. So let's see how that one also goes. Okay, so we have our solution. Let's rewrite the question or the formula. We have P is equal to M all over R squared plus K. Good. Now we are to make out the subject of this formula. So looking at this, you realize that we have a fraction within this formula. And as I said earlier on, whenever we have a fraction, we first have to clear the fractions so that we can proceed, or the question will become very simple for us. Okay, so let's clear the fractions. Now we can clear the fraction by finding the LCM and then multiplying each term within the formula by the LCM. So realize that we have r squared to be our LCM because we have p is said to be over 1, k is over 1, and 1 times r squared times 1 is still r squared. So we can say that our LCM is what? R squared. So LCM is equal to what? R squared. And then we are going to use this LCM to multiply each term within the formula. Are you following? Good. So we are going to get R squared times P is equal to R squared times M over R squared plus R squared times K. Good. So R squared times P will give us what? R squared P is equal to, we have R squared here, R squared here, so it will cancel out. So we have M plus R squared K. So realize that the fraction has been eliminated. We now have a linear equation. Good. Now intention is to make R the subject. So we have R here, R here. Why don't we group the R together? So let's do that. So let's bring the r squared k to the other side of the equation. So we are going to get r squared k minus r squared k is equal to m. Now we have r squared p, r squared k, r here. So why don't we factorize the r out? So let's factorize r squared out. We are left with what? P is equal to, now r squared is out. We are left with what? K. is equal to m. Let's continue from here. So we have our m is equal to r squared p minus k. Now we are looking for r, so we have to divide both sides of the equation by what? P minus k. So we have p minus k, p minus k. So that this will cancel this. We are left with what? R squared is equal to m all over p minus k. Now we are looking for r, not what? R squared. So we have to go back and then remind our previous introduction, the one that I did. So when you have a variable that is squared, to do away with the square, you have to square root both sides of the equation. So we are going to take the square root on both sides of the equation, and you realize that this square will cancel the root sign. We are left with what? R is equal to square root of m all over p minus k. That is that. Very, very simple. I'll give you one question on the squared variable and then you try your hands on it. Okay? So this is your try question. Pause the video, you solve it. Okay? So let's solve it together. So we have to make k the subject of this equation, okay? So let's rewrite our question. We have 1 over n. So we have this as our formula, but realize that the variable that we want to make the subject or to stand alone is squared, and it is under the radical sign or the root sign. So the first thing we have to do is that to do away with what the root sign, we are going to square both sides of the equation. First, we first have to do away with the root sign. First, okay. So let's square both sides so that this square will cancel this root sign. So that we are left with 1 over n squared. 1 times 1 squared is 1, n squared is what? N squared. Then we are left with k squared plus, I think it's a, so a squared all over hg. So this is what we are left with. Now realize that we have a fraction within this or at this very point. Okay, so we have to clear the fractions by what? Multiplying each term in the formula by the LCM. Okay, so let's find the LCM. So we have our LCM. What do you think the LCM will be? So the LCM is going to be n squared times what? Hg. So we have n squared hg. That is the LCM of this at this very point. Okay, so we are going to use the LCM to multiply each term in the equation. So we are going to have our LCM, which is n squared hg multiplying 1 over n squared. Let me use the black ink. So we have the LCM, which is n squared hg multiplying 1 over n squared, which is equal to the LCM n squared hg multiplying good. You realize that we have n squared here, n squared here. So that and that will cancel out. We are left with hg times 1 to give you hg is equal to. Now you also realize that we have hg. So this and that will go. We are left with n squared multiplying k squared plus what? A squared. Now we have to make what? K the subject. But this k is within a bracket. Okay, so we have to expansion. We have to expand this bracket. So let's do that. N squared times k squared, you are getting what? N squared k squared plus n squared times a squared will give you a squared n squared. Good. So we have expanded the bracket. Now looking at this, we have to make k the subject. Okay, so we have k here. Okay, we don't have k here. So we first have to transpose the whole of this term to the other side of the equation, so that we'll be left with what? N squared k squared. I guess you are following. So we are going to get hg, which is this one, and then minus a squared n squared is equal to n squared k squared. Now we have n squared k squared, but we want to make k the subject. So we divide both sides by n squared so that this and that will cancel out. Now we have our k squared is equal to hg minus a squared n squared all over what? N squared. Very good. Are we done? I guess you are saying no, because we have k squared. We want to make k, not k squared. So what do you think we can do? We can square both sides of the equation to cancel the square, so that this square will cancel the root sign, so that we are going to be left with k is equal to root of hg minus a squared n squared all over n squared. Very, very simple. Very, very simple. Okay, your task from the same preamble, make a the subject. So make a the subject from the same question. Okay, try your hands on that, and then let's see. So let's take our last example, and then we run out of here. Okay, this is our last example. We are to make x the subject of this relation. We are going to look at the one that involves a cube root or a power of 3. Okay, so we have one example here, and then we try our hands on it. Let's see. We have our solution. So let's write the question here. We have y is equal to as cubed minus b all over 3c. Good. Now realize that with this question we have a fraction, okay? A fraction which is what? 3c. And always when you have a fraction, you first have to clear the fraction within, okay? So looking at this, our LCM is going to be 3c. Good. So we are going to use the LCM to multiply each term within the formula. So we are going to get 3c times y is equal to ax cubed minus b all over 3c times what? 3c. You can see that this and that will go. We are left with 3c times y will give us 3cy. And then we have ax cubed minus b. Now, okay, let's continue from here. So we have 3c y is equal to ax cubed minus b. Now I want to make s the subject. So we have minus b here. Let's bring it to this very side. We have 3cy plus b is equal to ax cubed. Now we are looking for x. We have a variable attached to it. So let's divide both sides by a so that this and that will go. We are left with s cubed is equal to 3cy plus b all over a. Now we are looking for x. We want to make x the subject, not s cubed. So what must you do? We take the cube root on both sides of the equation. So let's multiply both sides of the equation by the cube root so that this power 3 will cancel the cube root sign, and then we have our x equals cube root of 3cy plus b all over a. Very, very simple. I guess you were following. I'm going to list questions for you to try your hands on it. Make sure you pause the video and then you do that, okay? So these are your set of questions that I prepared for you. I call them the tutorial set, okay? So you pause the video, you write them down, and then you try your hands on it. This brings us to the end of today's lesson. Kindly like, share, and subscribe to this very channel for more updates. See you next week. Bye-bye.